dy dx minus y over x equals 2y cubed cos x all over x squared. This is in the form that we want to apply Bernoulli's equation. So there's a y and a y cubed here. So let v equal y to the 1 minus n. Here's the n power. So it's minus 3. So v is equal to y to the minus 2 then, which we can write as 1 over y squared, can't we? So using properties of indices. So dv dx then will equal, will be minus 2 y to the minus 3 multiplied by the something differentiated, which is dy dx. So now we can rearrange for dy dx. So dy dx equals then, this y cubed is underneath really, it comes up to be on top with the dv dx. And the minus 2, the 2 can come down, and the minus is there, but the minus can be written on top. So there's dy dx, and here's v. So we can put them in. Substitution then. Substitution gives, what have we got? Dy dx is this. Minus half y cubed dv dx minus 1 over x times y equals 2y cubed cosine x all over x squared. Now we'll divide by y cubed all the way through. So divide by y cubed, see what we get. Minus a half dv dx minus, divide by y cubed, you'll get minus 1 over x, and there'll be a 1 over y squared here. And that's equal to then 2, the y cubed will disappear because you're divided by y cubed, 2 cos x all over x squared. So, let's times by minus 2 all the way through to see what we get then. So this will now become 1 lot of dv dx, which is what we want. Here, what have we got here? Times by minus 2, so that'll be a plus. It'll be 2 over x, won't it? Times, now this is v, 1 over y squared is v, so let's put that in now. And that will be, times by minus 2, it'll be minus 4, won't it? So minus 4 cosine x over x squared. Here's our p then. So let's circle that. This is an equation using the integrating factor method. We can try and solve it. So here, the integrating factor then is equal to e to the integral p, which is 2 over x dx. So put that in. Integrate it, you get 2 ln x, don't you? Move the 2 using properties of logs. It's ln x squared. Now these are adjacent to each other, they cancel each other out to leave just x squared, so to speak. So there's our integrating factor. So let's multiply this equation above by this. Multiply by x squared. See what we get. X squared of this. Plus 2xv equals minus 4 cosine x. Now we can circle the u and the v because they're clear to see. Here's u, in that position there's v. And we can now write d by dx of uv. So d by dx then of u times v x squared times v is equal to minus 4 cos x. Integrate both sides. Integrating. Gives. So the integral of this side will be x squared v. And we've got the integral of minus 4 cos x dx. The integral of cos is sine, so we get x squared v equals minus 4 sine x plus k. Now v is 1 over y squared, wasn't it? That's what we said at the outset. Let's just check that's the case. Yeah, there it was there. And right at the outset it's there, 1 over y squared, see it? So let's go back down. and put it in. So we've got x squared over y squared equals k. I'll write it in reverse order. Minus 4 sine x. Invert it then. So let's invert both sides. So y squared over x squared will equal 1 over k minus 4 sine x. Put a bracket around that, because now we're going to move the x squared up. Equals x squared over k minus 4 sine x. And now we just square root both sides, and we can get a solution for y. So y is equal to plus or minus, then it will be the x, won't it, when that comes out of the square root, all over the square root of k minus 4 sine x. And it's plus or minus, isn't it? So I'll put that at the front, just to make it look a bit more presentable. So it's plus minus x over that. Yeah, because we square rooted that, which gives you the y. Square root, we need the plus or minus. There's the possibilities. The square root at the top is x. The square root at the bottom is that. And then we write the plus or minus.